Alright, we're going to take a look at solving a system of equations using the elimination method. Now, this is a little bit different than substitution, but the goal is still the same. We still need to find an ordered pair x, y that will work. It'll be a solution to both of these equations. The way elimination works, it doesn't involve substituting into a variable or anything like that. It involves adding one equation to the other in order to eliminate or cancel out one of the variables. So if you're using this method, what you should first start out with is making sure that your equations in your system are all lined up. So you have your x terms in a column, you have your y terms in a column, your equal signs in a column, and your constant terms should be in a column also. So what we should have to begin with, your x and y terms should be on the left side and your number terms should be on the right. Then you want to take a look at trying to eliminate one of the variables through addition. So what you want is opposite coefficients. And I'm looking at this right now and I see that I have a negative 3y and a positive 3y. And if I added those together, I would get 0y and it would cancel that y term out. So that's exactly what I'm going to do. I'm going to add down these two columns. So x plus 5x is 6x. Negative 3y plus 3y is 0y, and negative 5 plus 119 is 114. So what this does for us now is the 0y term, that's gone. We don't have any y at all. All we're left with is 6x on the left is equal to 114 on the right. So we're going to go ahead and divide both sides by 6. And let's see, x is going to equal, what do we have there, 19. Now that we know what x is, we need to take that value, substitute it into one of these equations, and solve it for y. So I'm just going to go back to that first equation and use that. So x is 19 minus 3y, we're going to find, is equal to negative 5. So now we're just solving this equation for y. I'm going to subtract 19 from each side. So negative 3y is equal to negative 24. Divide both sides by negative 3, and y is equal to 8. So it looks like we have a solution here that is 19 for x and 8 for y. Now I'm pretty sure that's right, so let's go ahead and check it and be positive that it is. So we'll just take that ordered pair, substitute it back into those equations, and if it's the solution to the system, it'll work in both. So x is 19 minus 3 times y is 8 is equal to negative 5. So 19 minus, I got 24 is equal to negative 5. And 19 minus 24 is negative 5. So that one worked. Go back into the other one. 5 times x is 19 plus 3 times y is 8. And that should equal 119. So let's see, we've got 5 times 19, 50 plus 45, we've got 95, plus 3 times 8, we've got 24, should equal 119, and 95 plus 24 does equal 119. So it worked in both, so that is our solution. Alright, next example we're going to take a look at is a little bit different here because not everything is lined up in columns. We do have the x term all lined up in columns, but the equal signs are out of place. So here we have the y term on the right, and here we have the y term on the left. So really we need to get the x's and y's on the left side and our constant on the right in order to add these together effectively. So I'm going to take this first equation and we'll need to get rid of that 2y that's on the right. So we'll subtract it away. What that's going to give us is on the left side 5x minus 2y, and on the right side we're left with negative 12. That second equation, there's nothing we need to do with that because 3x plus y, those are on the left, and 39 is on the right. Now, if we added right now, we would have 8x and negative 1y, and that wouldn't solve the problem of having two different variables. We need to have opposite coefficients. We need to cancel out either x or y. So I'm looking at this and seeing that if I multiplied the second equation by 2, I would have 2y here to go with the negative 2y up here, and those would effectively cancel out. So I'm going to go ahead and multiply the second equation by 2, and that will give us 6x plus 2y is equal to, we got 39 times 2, is going to be 78. Then we're going to bring this one over. We have 5x minus 2y is equal to negative 12. Now when we add down these columns, 5x plus 6x will be 11x, negative 2y plus 2y is 0y, and negative 12 plus 78 is 66. So the 0y term, we can get rid of that. All we have left is 11x equals 66. Divide each side by 11, and x is equal to 6. Now that we have x, we'll need to find y, so we'll take that value, go back into any of these equations and substitute it in to find y. So I'm going to just go back to this second equation here, because y is, is just plain y. All we'll have to do is a little bit of work. So 3 times x is 6 plus y is equal to 39. Well, we got 3 times 6. That is 18 plus y is equal to 39. And we'll subtract 18 from each side. So y is equal to 39 minus 18, we've got 21. So it looks like we've got a solution here of 621. But we'll check that and make sure. So go back to that first equation. We've got 5 times x is 6. That should equal 2 times 21 minus 12. So that's 30 is equal to 2 times 21 is 42 minus 12, and 30 is equal to 42 minus 12. So that one works. Second equation says 3 times x. We know that x is 6 plus y, that's 21. This should equal 39 if it works. So 6 times 3 there is 18 plus 21, and 18 plus 21 is absolutely 39. So it does work, and that solution is good.